Imagine a world devoid of humans. No cities, no highways, no smartphones, no internet, just the relentless march of time, mountains rising and falling, oceans carving continents, and life quietly evolving in hidden corners of the planet. Now imagine that in this world, millions of years ago, there was something else, something intelligent, a civilization that lived, built, created, and vanished, leaving almost no trace behind. It sounds like science fiction, a story from the imagination of a novelist. Yet in 2018, two scientists dared to ask the question seriously. Could we, modern humans, really be the first technologically advanced civilization on Earth? This question gave birth to what is now known as the Silurian Hypothesis. The name itself is evocative. Silurian calls to mind an era hundreds of millions of years before humans, a time when life on Earth was dominated by strange fishes and the first plants began to crawl onto land. But it isn't tied strictly to that period. It's a symbol, a placeholder for any time in Earth's deep past. The real question is broader. Could some other species, somewhere in Earth's history, have developed the technology and societies we consider uniquely human? And if so, why don't we see evidence of it today? We tend to think of history as a timeline with a clear beginning. Humans appear, civilization rises, science progresses. But geologic time doesn't care about human timelines. 1 million years is barely a heartbeat. 100 million years can erase entire continents and their histories. Erosion, tectonic shifts, glaciations, volcanic activity. These forces sweep away evidence of the past with a quiet thoroughness that makes it almost impossible for any civilization, no matter how advanced, to leave lasting marks. And yet, the idea persists, haunting our imagination. What if the ruins of an ancient intelligence lie hidden beneath our oceans, buried under miles of sediment, or transformed beyond recognition by the relentless march of geologic time? The Silurian Hypothesis doesn't claim we know this happened. There is no fossil city, no ancient supercomputer fossilized in stone, no concrete proof. Instead, it's an intellectual experiment, a question that forces us to examine what we assume about human uniqueness and what signs a civilization might leave behind that could survive millions of years. It is in this silence, in the absence of evidence, that the hypothesis is most provocative. It whispers to us across the aeons. Perhaps our story is not the first. Perhaps Earth has hosted intelligence before, a fleeting spark in the vast darkness of deep time, whose echoes we are only beginning to imagine. In the chapters to come, we will dive into the science that makes this question compelling. We will explore the deep history of our planet, the extraordinary forces that erase and preserve evidence, and the methods scientists propose to detect civilizations that may have arisen and disappeared long before humans ever walked the Earth. But first, to understand what it would take to uncover such a lost civilization, we must learn to read the Earth itself, not as a static stage, but as a time machine, carrying traces of everything that has ever lived upon it. To imagine civilizations older than humanity, we must first confront a truth that is both humbling and terrifying. Earth has a memory, but it is imperfect. The planet remembers life in fragments, fossils, isotopes, mineral deposits. But it rarely preserves the delicate intricacies of cities, machines, or human-like artifacts. Time is relentless. Mountains rise and crumble, rivers carve valleys, glaciers grind continents to dust, and oceans swallow coastlines whole. Consider the scale. Humans have existed for roughly 300,000 years. Modern civilization, with its sprawling cities and technological marvels, is barely 10,000 years old, a blink of an eye in geologic time. Now imagine a civilization that arose 100 million years ago, during the age of dinosaurs. By the time mammals began their quiet ascent, almost every trace of that civilization could have vanished. So how would we even know it existed? Scientists turn to the Earth itself. Rocks are time capsules, and within them lie chemical signatures that whisper secrets of the past. Elements like carbon, oxygen, and sulfur carry isotopic ratios that can reveal unusual patterns, clues of processes that don't occur naturally in isolation. For example, massive fossil fuel burning leaves a distinct isotopic fingerprint in sediments. Could an ancient civilization millions of years ago have left a similar trail? Paleontologists and geologists also look at stratigraphy, the layers of rock that accumulate over eons. A sudden layer of industrial pollution, an abrupt change in sediment composition, or the unusual presence of metals in unexpected contexts could all be subtle hints of intelligent activity. Yet these signals are fleeting. Plate tectonics recycles the Earth's crust, erasing vast swathes of history. Volcanoes bury regions under lava. Glaciers scrape continents clean. Even a civilization as advanced as ours might leave almost no permanent trace after millions of years. Fossils are another crucial record, but they too are biased. Bones, shells, and plant material can fossilize, but technology rarely does. Plastics degrade over centuries. Electronics corrode within decades. Concrete, our civilization's most enduring material, might survive thousands of years in some conditions. But given millions or tens of millions, even concrete crumbles to indistinguishability. This is why the Silurian Hypothesis is so fascinating. It asks scientists to think in deep time, to imagine the Earth not as a snapshot of human history, but as a dynamic, evolving planet. If an advanced civilization had existed long before us, it would be vanishingly difficult to detect, not because it didn't leave a mark, but because the planet itself relentlessly erases it. Yet even in this apparent silence, there are possibilities. Geochemical anomalies, microscopic structures in sediment, or unusual concentrations of rare metals could act as breadcrumbs, leading us to discoveries that challenge everything we think we know about life on Earth. Detecting these clues requires patience, ingenuity, and a willingness to look for evidence in places most would consider barren or unremarkable. In essence, the search for a lost civilization is not just archaeology. It is geology, chemistry, and imagination intertwined. We must learn to read the subtle language of the Earth, translating chemical signatures and rock formations into the story of a civilization that may have arisen, thrived, and vanished long before humans ever existed. If a civilization existed before us, what might it have been like? We have no fossils of cities, no ancient blueprints, not even a broken wheel from millions of years ago. All we have are the faintest hints in the fabric of Earth itself and the imagination of scientists daring to speculate. To begin, we must strip away our assumptions about what a civilization must look like. Humans build with wood, metal, concrete, and silicon, but an intelligent species millions of years ago might have used materials we can barely imagine, or ones that decay completely over eons. Perhaps they harnessed stone, ceramics, or biotechnologies that leave almost no durable trace. Perhaps their cities were not sprawling concrete jungles, but subterranean networks, vast ecological constructs, or even orbital installations now lost to the void of time. Even if their structures were physical, the planet is unkind to permanence. Tectonic activity can obliterate continents. Sedimentation can bury entire civilizations under kilometers of rock. A city that thrived 200 million years ago could now be scattered in fragments across mountains, transformed into unrecognizable minerals. Roads, bridges, and buildings would dissolve, leaving only geochemical fingerprints, slight enrichments of metals, unusual carbon isotope ratios, or sediment layers showing signs of mining or energy use. Then there is the question of energy. Any advanced civilization requires energy, and energy use leaves detectable traces. Fossil fuel consumption, nuclear reactions, or industrial-scale metal smelting would all alter local chemistry. Millions of years later, those changes might be preserved in the rock record if we know what to look for. Scientists speculate that a technologically advanced species could leave behind isotopic anomalies that future geologists, us, hypothetically, might detect even if no physical structure survives. Consider the society itself. Would it resemble ours, with centralized governments and sprawling cities? Or might intelligence manifest differently as a highly distributed network of small communities interacting over vast landscapes? Could communication have been non-verbal, using chemical or electromagnetic signals we barely understand? The farther back we go, the more speculative these ideas become. But speculation, guided by scientific reasoning, is exactly what the Silurian hypothesis demands. Even their culture, art, language, and knowledge would likely vanish without a trace. Paper decays, metals corrode, and plastics break down. Only the most extreme materials like ceramics or dense alloys could survive millions of years, and even then, only in highly favorable conditions. What survives then might not be a library of knowledge, but subtle alterations to the planet itself, landscapes reshaped by mining, forests cleared and regrown, isotopic ratios changed by energy production. In a sense, the hypothetical ancients would be like ghosts. We may never see them directly, but their presence could be inferred from the faintest distortions in the world around us. It is a civilization defined not by monuments or artifacts, but by its subtle, almost imperceptible impact on Earth. And yet, despite their disappearance, the implications are profound. If such a civilization ever existed, it would shatter our assumptions of uniqueness. Humanity would not be the first species to reach for the stars, to manipulate its environment on a planetary scale, or to experience the fragile thrill of technological progress. We would be inheritors, not pioneers, in a long continuum of intelligence that the Earth has nurtured and erased. Even the most advanced civilization is fragile in the face of geologic time. Earth is not a museum, it is a furnace of constant change, and it shows no mercy to the creations of any species. Mountains rise and crumble, oceans swallow continents, and climates shift with relentless unpredictability. For a civilization to leave behind almost nothing, it would need to survive not just the passage of time, but catastrophe itself. Consider mass extinctions. Over the last 500 million years, Earth has endured at least 5 major extinction events. The Permian-Triassic extinction, 252 million years ago, wiped out over 90% of marine species and 70% of terrestrial vertebrates. The Cretaceous-Paleogene extinction, 66 million years ago, famously ended the age of dinosaurs. Such cataclysms leave few survivors and even fewer traces. A civilization caught in these upheavals, volcanic winters, asteroid impacts, climate chaos, might be obliterated, its structures crushed, its cities submerged, its knowledge scattered like dust. Even smaller-scale disasters, mega-floods, supervolcanoes, shifting tectonic plates, can erase human-scale constructions in moments of geological time. The Earth's surface is constantly recycling itself. Continents drift, mountains erode, rivers reshape valleys. What may have been an empire once could now exist only as faint chemical anomalies buried beneath miles of sediment. Climate itself is another silent destroyer. Ice ages grind landscapes into gravel, oceans rise and fall, submerging coastal settlements. A civilization could thrive for millions of years and yet leave almost no lasting trace, because Earth's climate is not static, it is an unending reshaping force. Even without catastrophe, entropy works against permanence. Metals corrode, plastics break down, concrete crumbles, and stone weathers. Only the most resilient materials, dense ceramics, certain alloys, or buried structures in geologically stable regions, might survive the passage of tens of millions of years. But these survivors would be fragmented, eroded, and difficult to interpret without context. The silence we observe in the fossil record is therefore not evidence that a civilization never existed. It may simply reflect the hostile nature of deep time. The Earth is a relentless archivist, but one whose memory is incomplete, selective, and unforgiving. It preserves some signals with exquisite detail, while erasing others entirely. This is why the Silurian hypothesis is both thrilling and unnerving. It suggests that humanity's apparent uniqueness may be an illusion, a product of how easily Earth erases traces of intelligence. Somewhere beneath the oceans, in deep rock layers or scattered across eroded mountain ranges, there could be chemical whispers of civilizations long vanished, and yet these whispers are faint, nearly impossible to detect, requiring scientists to think not like historians, but like planetary detectives, piecing together the story of a civilization from the tiniest anomalies. If an ancient civilization once existed on Earth, its traces would be subtle, nearly invisible to conventional archaeology. To find evidence, scientists must turn to methods more akin to detective work on a planetary scale than to digging for pottery shards. The search is not for ruined statues or fossilized cities, it is for ghosts, lingering hints that something intelligent once shaped the planet. One of the most promising approaches lies in geochemistry. Human civilization, even in a few thousand years, has left an indelible mark on Earth's chemical signatures. Fossil fuel burning alters carbon isotopes in the atmosphere, creating patterns preserved in sediments. Large-scale metal production leaves anomalies in soil composition. If an advanced civilization existed millions of years ago, it might have left similar isotopic fingerprints. Subtle deviations in carbon, oxygen, or nitrogen ratios preserved in sedimentary rocks. Detecting these anomalies requires precision, patience, and an understanding of natural geological processes, so that we don't mistake ordinary phenomena for signs of intelligence. Another avenue is mineralogical and structural anomalies. Human activity produces materials that do not typically occur in nature, certain alloys, plastics, concrete, and ceramics. Over millions of years, most would degrade, but some compounds might persist in unusual concentrations. For example, traces of metals concentrated by mining or ceramics buried in sediment could survive as microscopic clues, tiny echoes of a vanished civilization. Even fossil fuels themselves could be indirect evidence. Our use of coal, oil, and natural gas dramatically altered the carbon cycle. If an ancient civilization relied on similar resources, their energy use might have shifted isotopic ratios in sediments or left patterns in hydrocarbon deposits. These chemical breadcrumbs would not scream civilization, but careful analysis could reveal anomalies that defy natural explanation. The oceans also hold potential clues. Sediments accumulating on the seafloor preserve detailed records of chemical and biological activity. Layers containing unusual metals, synthetic compounds, or isotopic anomalies could hint at industrial activity. Similarly, glacial ice can trap atmospheric gases and particulates, offering a frozen snapshot of Earth's past. Yet, even with these sophisticated methods, the challenge is enormous. Earth is an ancient, dynamic planet, and natural processes can easily mimic the signs of intelligence. Volcanoes produce metals, natural fires release carbon, and microbes can concentrate unusual elements. Distinguishing between natural and artificial signatures requires extraordinary rigor, along with an open mind to possibilities that challenge our assumptions. Despite the difficulty, the search is more than academic. It is a profound experiment in thinking beyond human timelines, questioning our uniqueness, and stretching the limits of science. Each sediment sample, each isotope measurement, each chemical anomaly is a piece of a puzzle that may someday reveal whether humanity is truly the first species to wield intelligence on a planetary scale, or just the latest in a long series of experiments by life on Earth. If the Silurian hypothesis holds even a glimmer of truth, it would fundamentally reshape how we see ourselves. Humanity has long clung to the belief that we are unique, the first species to build cities, harness energy, and reach toward the stars. But the possibility that intelligence has arisen and vanished before us forces a humbling question. Are we pioneers, or merely the latest echo of a much longer story? Imagine standing on a barren plateau, holding a fragment of rock that contains chemical anomalies, pointing to industry millions of years before humans. There is no city to explore, no fossilized statue, no book to read, only the faintest traces in stone and sediment. Yet in that whisper, you glimpse the grandeur and fragility of life. Intelligence is not eternal. Civilizations rise and fall, leaving behind not monuments but faint impressions that may endure only until the next catastrophe or geological cycle. This perspective invites reflection not only on our past, but on our future. If civilizations can disappear almost entirely despite their power and ingenuity, then humanity is not immune to the same forces. Climate change, nuclear weapons, pandemics, or cosmic events could erase our cities and technology, leaving only subtle chemical footprints for any future species or explorers from elsewhere in the galaxy to find. The Silurian hypothesis, then, is not merely a thought experiment, it is a cautionary tale. It also reframes our understanding of intelligence itself. Life may have more opportunities than we imagine to reach technological sophistication. The Earth may have hosted multiple intelligences over its history, each experimenting with tools, energy, and social structures, only to vanish without a trace. Our story, long viewed as unique, could be one of many iterations of a repeating cosmic pattern, life rising, reaching, and fading, leaving the planet itself as the only witness. Finally, the hypothesis challenges the way we think about exploration. If signs of ancient intelligence are hidden in sediments, isotopes, and minerals, then the search for other civilizations may begin not in the stars, but beneath our feet. Perhaps before looking to exoplanets for intelligent life, we must first look within our own deep past, questioning what we know about life, history, and our place in the cosmos. The Silurian Hypothesis leaves us with more questions than answers, but that is its power. It reminds us that silence is not evidence of absence, that Earth's history is vast and often incomprehensible, and that intelligence, however fleeting, leaves marks that may endure in forms we are only beginning to learn to read. So the next time you walk through a city, touch a building, or fire up a computer, consider this. In the grand expanse of deep time, our civilization is ephemeral, our achievements fragile. And yet, in that fragility lies something remarkable, the capacity to wonder, to imagine, and to ask questions that stretch across millions of years. Were we really the first? Or are we the latest chapter in a story that began long before humans ever walked the Earth? The answer for now lies in the rocks, the sediments, and the whispers of time itself.